And welcome everybody to the Daily Space Weather. We're looking at the sun here in 304 angstroms. Ionized helium, ultraviolet light emitted from ionized helium. By the way, I'm your host Dan, aka smAsho. And we see solar minimum conditions return. We'll be talking cosmic rays and lots more on today's Daily Space Weather. Here's another view of the closest star. This is 193 angstroms. This is ionized iron, and we see a coronal hole system facing the Earth. And we've got north and south pole oriented coronal holes creeping toward the solar equator. So this one's south pole oriented. This one up here is north pole oriented as they are reaching toward the equator. And once again, I would remind you that Cycle 25 is taking its good old time to continue. Next thing we're going to do is take a look at the view from Lagrangian point 5 as we saw a coronal mass ejection. Lagrange point 5 located right here, trailing the Earth by a few weeks orbitally speaking. And here's the view from Stereo A's coronagraph. And we caught a small diffuse coronal mass ejection on the far side of the sun. So right there you can see that little coronal mass ejection coming out. And for you new viewers, from the perspective of Stereo A, Earth would be located off to your right. So Earth would be off in this direction from Stereo A, and you can see that coronal mass ejection not Earth-facing at all. It's basically just a fireworks display. One thing I would note is the way that this bubble of plasma has kinked this plasma jet. You can see this area right here, this prominence that's sticking out here. You can see the way it is distorted as that bubble of plasma flows past. See the way that jet gets kinked and perturbed by all of those charged particles, primarily made of hydrogen nuclei. So a lot of protons there blasting out. And next we're going to look at the viewpoint from Lagrangian point 1 here at the SOHO LASCO C2. And you can see some evidence of that coronal mass ejection there off on the eastern side, which would be your left from the perspective of Lagrangian point 1, located about 1 million miles closer to the sun than the Earth at the equilibrium point, L1, Lagrangian point 1. Here's another ionized iron view. This is 211 angstroms. And I would note that there is very little plasma in the Earth-facing zone here around the equator, but there still are filaments both in the south and northern hemisphere of the sun. Likelihood of additional coronal mass ejections is still there, despite seeing sunspots setting at the southwestern limb. So down here, these sunspots, a group of 3. One of them is decayed to plage, and the 2 other ones have set below the limb. Here's the magnetogram of those sunspots. They are 2818, 2820, and 2821. This area of magnetic organization up here is not a sunspot. Has not been a sunspot as far as I know. I didn't see any umbra. And continuing on, here's a diagram of the solar system. We show it daily to give folks an idea of where things are located. So here's where things are now. And welcome to May, by the way. Here's where things will be in a week approaching another new moon. Here's a star chart. I've drawn in the ecliptic here, which is this yellow line, the path the sun will take across the sky. If you want to create your own star chart, head to in-the-sky.org, put in your location. You can make a star chart just like this for your location. You can also advance it if you like by bringing out this sidebar here. If you press that button there, you can see the way things will advance at your location. Continuing on with the radio flux, which has sunk all the way down to 73, folks. It's legit solar minimum conditions right now. And the sun emits radio frequency from its upper chromosphere and its lower corona in the variety of 2800 megahertz. 2800 megahertz is the frequency of the 10.7 centimeter radio flux. 10.7 centimeters is the amplitude. And what you're talking about when you're talking about the radio flux is the flux density of that radio output, 73 solar flux units. And a solar flux unit is equivalent to 10,000 joules, if you're wondering. This is the one-year chart as reported by Solon.info. The black line is the radio flux, and the red line is the sunspot number. You can see how proportional they indeed are. And we do also see NOAA forecasting geomagnetic unrest conditions early in the day tomorrow, Sunday, May 2nd, and early in the day, Monday, May 3rd. Must be coronal hole wind streams. I don't know. There's a lot of data not being reported right now, folks. And speaking of data being reported, let's take a look at cosmic rays. Here is the cosmic ray scenario from the Apatity Neutron Monitor and the Barentsburg Neutron Monitor. And you can see at Apatity, it's quite flat here over the past 30 days. Barentsburg, a small downtick over the past 30 days at Barentsburg. Let's go farther south to Athens, Greece. And there's the 30-day chart from the Athens Neutron Monitor. Small downturn in cosmic ray flux there. The Athens Neutron Monitor now even farther south to Mexico City. Small downtick at the Mexico City Cosmic Ray Observatory. And next we'll look at Oulu, Finland, and 2 Antarctican monitors. So going back way north to Oulu, Finland, to see a flat chart on the past 30 days. DOMC Antarctica. Small downtick over the past 30 days there. And DOMB Antarctica. A larger range, but a similar overall graph. Downtick at DOMC Antarctica. And let's move into the realm of earthquakes. We report it daily here at the Smash News Network. Least busted. Name in news. Largest quake of the past 24 was a 6.8 off the coast of Japan. That is the location of that. There were no tsunamis expected nor reported to my knowledge from that nearly 7 magnitude quake. Let's check the entire list. And we're just going to scroll up the list here. It looks like things have calmed down off the coast of Oregon. Here's a 3.0 magnitude quake at 400 meters above sea level at Pahala. Let's check the location of that Hawaiian quake. And it's at the lower slopes of Mauna Loa there. Anyway, there's the location of that extremely shallow quake, 400 meters above sea level. Bande Aceh saw a 5.1 magnitude quake. There was a 4.2 magnitude quake at Timor-Leste. South of Africa, there is one between the African and Antarctican plate boundaries. The Mid-Indian Ridge saw a 5.2. That 6.8 came in at 1:27 Universal Time this morning on May 1st. Also, we saw a deep quake near Saipan. That 4.3 magnitude quake at 305 kilometers deep. That would be like a 5+ magnitude quake if it happened at the surface. But it didn't. It was 300 kilometers depth. Continuing on to volcanoes. I want to know what's erupting, do you? Here's the list. Sakurajima's on the list. It's producing an 8,000-foot ash plume. Suwanosejima, 4,000-foot ash plume. Dakono, 8,000-foot ash plume. Popocatépetl, 20,000-foot plume of volcanic ash above it in central Mexico. Guatemala sees Fuego exploding, 15,000-foot ash plume there. And Nevado del Ruiz, the Colombian volcano, now back on the list as it explodes, 19,000-foot ash plume over Colombia. Revenador in Ecuador exploding, 14,000-foot ash plume. And Sabancaya also producing a 24,000-foot plume of volcanic ash as it explodes. Which brings me to my next point. Please don't pole vault the caldera. Why are we telling you this? Because people are stupid, and we're selling awesome merch with this amazingly high-resolution design at massive personal risk and expense. You can link to it at smashomash.com, where we welcome you to the neo-renaissance. Thanks for viewing the videos. Check out our links and so on. You can find our social media, as well as links to our merch shops. There's a SmAsho store and a Smash store and a SmAsho merch. The SmAsho merch shop will lead you here. And today's featured product is the Do Not Pole Vault the Caldera tote bag. Now, Mother's Day is coming, and we ordered one of these for Smash staff's mom and for my mom. They'll send you an email confirmation, and they'll send the products as a gift, or they won't tell anybody how much they cost, I guess. Do not pole vault the caldera, because people are stupid. And that's why the public service message exists. People need to be told not to pole vault the caldera, folks. I find it shocking. What about you? Let's get back to the GOES 16's sun-facing suite of instruments. No major solar flares over the past 24 hours. Nothing even in the C-class range on the 3-day chart there from the GOES 16 X-ray flux. And don't get solar flares confused with coronal mass ejections, folks. Solar flares are photons. Coronal mass ejections are primarily made of protons. We don't see any spikes in the proton flux either. No surprise there. We would have forecasted it, most likely. Here's the GOES magnetometer. We saw some pretty high readings here. Some of the higher readings we've seen in a few days, making it up to 137 nanotesla, and then a precipitous drop-off. And if you're wondering what the N's and M's mean, those are noon and midnight local time for the GOES 16 satellite. And we see a rising magnetometer reading now. It looks like there is a coronal hole wind stream showing up a little early, folks. We saw solar wind densities reach all the way up to at least 26 protons per cubic centimeter. We'll get to it in a minute. First, the top view ecliptic plane field plot. Now you're looking at the heliospheric current sheet and the polarity thereof. And those lines are potential field surface source lines. You can see the Earth is solidly in a North Pole-oriented current sheet shown here in green. And we're expecting a South Pole current sheet to come through in about 36 hours would be my guess. Here's another view of the same data from the line of sight. It's essentially a three-dimensional drawing of the magnetism of a heliospheric current sheet. Here's another view. This is the line of sight coronal hole plot, and I'm not sure why it's not showing these coronal holes. You would expect it to show a North Pole-oriented coronal hole about here and a South Pole-oriented coronal hole about here, but for some reason not showing them on this imagery. It could be because there's plasma in the way, and plasma has the ability to block the sensing of the location of the magnetic fields as it obscures the polarization of light, which elicits the location of said magnetic fields. Here's the detected sunspot groups imagery. And you can see sunspot 2018 and 2818 and 2820 are in their setting mode. They will both lose their names today. Here is the KP index measurement of global geomagnetism at 1 geomagnetic calm conditions, despite the increased solar wind density. So we saw an uptick in the solar wind density here over the past 24 hours. And let's see, the highest spikes here were under 30 protons per cubic centimeter. So making it up to about 27 protons per cubic centimeter here. It looks like the leading edge of a coronal hole wind stream if I've ever seen one. And we're expecting to see the solar wind density drop off and the solar wind speed come up as coronal hole high-speed stream arrives at the geospace. Speaking of the geospace, here's the magnetohydrodynamic pressure. And we see a pretty spaced out plasmasphere here. So these little areas right here where there's very low pressure, that's the plasmasphere. As material gets trapped in those regions, held in by the ions around it and the electrons. And anyway, that's 4 hours of data courtesy University of Michigan. Here are ground magnetic perturbations. Now we're looking at geospace delta B, changes to the Earth's B field in nanotesla. The last one was in nanopascals. This is in nanotesla. Nanotesla, a measurement of magnetic flux, not quite the same as the magnetohydrodynamic pressure. This is also 4 hours of data. We show it daily since it's not archivally accessible. Perhaps in the future. Most of the perturbations in the northern hemisphere. And let's welcome Twitch. Welcome, Twitch. We've decided to stream live to Twitch for today's cosmology segment. It's going to be pretty short. And if you don't follow us on twitch.tv/smAsho, you may not see all the content. They've got a great mobile app, by the way, which will notify you when we go live. Twitch.tv/smAsho. We're also on BitChute. Thanks to our YouTube subscribers. If you're new to the channel, please don't forget to press like and subscribe and share. Tell your friends and foes about the content. Tell your neutrals as well. There is exclusive content on BitChute, as well as on all of our social media sites. And here comes today's Cosmology segment, where I'll talk at a stilted voice for no apparent reason. Here at the Smash News Network, least busted name in news, we're interested in cosmology. As it turns out, astrophysics, geology, and all kinds of other physical sciences are being rewritten, as I've been saying for years. Thank goodness for this neo-renaissance. Here's the astronomy photo of the day. It's a view from the Mars Ingenuity helicopter. I think this was on its third flight. This is from the April 25th flight at just over 5 meters, about 16 feet above the Martian surface. Congratulations. And today's random number is 70, which coincides with an object at the Neil Gorell Swift-Bat X-ray Observatory. It's 2MASS J02093740 plus 5226396, which is a Seyfert 2 galaxy, a type of active galactic nucleus. There it is on the Pan-STARRS imagery. And we're at Aladdin light here. Let's take a look at it on the 2MASS. Here it is in infrared light. And we don't see it on the Chandra or the XMM Newton. Let's take a look at it in blue light before we move on. This random object here is, again, it's a Seyfert 2 galaxy, which is a type of active galactic nucleus. Let's go back to its X-ray outputs. Here are its X-ray outputs, and you can see it has quite a wide range here, this particular galaxy. It's got a pretty big range, and it's been known to produce some pretty strong transients. Interestingly, it produced a dense series of X-ray bursts here in the past few days. And we actually saw that from several different sources. I noticed a similar signature in Cygnus X3 the last time I looked at it. That data is all available at the Neil Gorell Swift Observatory, the Burst Alert Telescope hard X-ray monitor. Let's talk about white dwarfs. It is a mystery, folks, where white dwarfs get their strong magnetic fields from. And I'm not going to really conjecture about this one very much. I'm just going to refer you to the article here. You'll find this one all over the Science Wire today, as we did at Smash News Network, least busted name in news. Let me read a quote. This research could solve a decades-old problem. The beauty of our idea is that the mechanism of the magnetic field generation is the same as in planets. This research explains how magnetic fields are generated in white dwarfs and why these magnetic fields are much stronger than those on Earth. Now, why we're comparing the magnetic field of a star to the magnetic field of a planet, I don't know, but this particular author thinks it's a good example of how an interdisciplinary team can solve problems that specialists in only one area would have difficulty with, Schreiber adds, which would bring me to a quote from Pierre-Marie Robitaille. Many times, folks, advances in science, such as cosmology, occur because of outsiders getting into the field. Why is that? It's because outsiders provide a unique perspective. So the same way I provided some physics consulting for my pal when he was in a PhD program in organic chemistry, you could say biomechanical engineering, but whatever. He was in a PhD program, and I provided some refreshing insight into some problems by looking at the chemistry problems from a physics perspective. This is one of the many reasons why outsiders are often very valuable in the realm of science. You'll find this article all over the Science Wire today. The likely mechanism, a dynamo, that generates huge white dwarf magnetic fields. As these objects are not properly understood, white dwarfs typically are part of a binary system, and I won't get super in-depth into what white dwarfs are. According to the concordance model of stellar evolution, white dwarfs are stars that have cast off their outer shells as a result of the alleged stellar life cycle. I'll just leave it there. And that's today's cosmology segment. We'll have to say goodbye to Twitch. Bye, Twitch. We'll bring you back for the meteorology segment. And let's continue on here with the daily space weather. Next thing we'll talk about is the electron flux. Here's a 1-year chart of the electron flux. And by the way, if you're wondering where this is measured at the F ionosphere layer at about 300 kilometers by the GOES-16. So the GOES-16 uses radiography from its geostationary orbit to measure the electron density. Here it is. Here is the electron density over the past 3 days, as measured by the Earth-facing suite of instruments on the GOES-16, the GOES electron flux. It did get into warning territory briefly, as we forecasted yesterday on the Daily Space Weather video, and now it has cratered, which is typically what we see when coronal hole wind streams arrive, which is, I believe, what's happening now. We don't see any charging hazards for satellites, which is the main danger of high levels of electron flux, which can do things like cause communications breakdowns and so on as these satellites turn themselves off in an event known as a CCD bakeout, where they shut off their charge couple device in order to not damage their sensitive electronics. So here's the forecast for electrons, and you can see my forecast yesterday was exactly right. I literally put a dot exactly where that observation is. Cheers. We forecast things nobody else is able to on the channel. Congratulations to us. Maybe one of these years we'll actually reach 2,000 subscribers. Here's a diagram of the Van Allen belts of planet Earth. Distances are shown here in miles. Continuing on to show a visualization of the total electron content. And anomalies in this will show you where likely GPS errors will occur. The darker the blue, the less likely you are to see significant GPS errors. The most likely place on the planet to see them is on the equator around noon. Here's another visualization of the atmosphere. This is showing distances in kilometers. And about 300 kilometers of altitude is where the F ionosphere layer is, which is what we're now looking at. Here's an animation of that. And you're looking at the vibrational frequency of the ionosphere in megahertz. Pretty anomalous here. We're seeing some pretty significant anomalies here in the shape. Those blobs down there in the southern hemisphere, where you see that large yellow and red area, that is quite anomalous, actually. There's just this area right here of low frequency just hanging out. Keep in mind the resolution's only 1 megahertz on this. A fairly anomalous ionosphere. I don't know how else to describe it. It's just not looking normal to me. Leave us a comment if you have theories about the anomalies in the ionosphere. There's the current imagery from when we recorded the video at 10:45 Universal Time. And now it's time to bring back our Twitch viewers. So we've gone live once again. Welcome back to our Twitch viewers. And we're starting out with an article here on climate. So I don't know what I clicked on there. Let's get this party started, right? Let's get this party started quickly, right? 400,000 years ago, it looks like permafrost may have thawed when temperatures were not much higher than today. Oh, noes, the permafrost. The permafrost could melt, folks. Oh my God, are you scared? Are you scared and spooked by this? Cave deposits reveal Pleistocene permafrost thaw absent predicted levels of CO2 release. Now, if you're frightened of CO2, please leave us a comment. Leave us a comment if you believe carbon dioxide is a pollutant. By the way, CO2 is not a pollutant and should not be removed from the atmosphere, as it's the basis of all earthly food chains. Maybe not for extremophiles, but for the rest of the planet, photosynthesis lies at the base of all major global food chains. Carbon dioxide would optimally be at about 1,200 parts per million, does not control the climate. But lots of people are very worried. So here's an article from SciTech Daily about, oh my God, cave deposits reveal permafrost thawed 400,000 years ago when temperatures were not much higher than today. Let's talk about when temperatures were not much higher than today. 33 million years ago. 33 million years ago are when the Antarctic ice sheets began to form. Guess how hot the Earth was back then, 33 million years ago? It was 3 degrees Celsius warmer than it is today. 3 degrees Celsius warmer when Antarctica began to glaciate. Which brings me to this next chart. If you've got people who are complete climate invalids, who know absolutely nothing about the geologic record, notice how the current trend is the lowest temperatures since 300 million years ago, and the lowest levels of carbon dioxide since 300 million years ago. Way up here, right about there, is where Antarctica started to form. And you can see how much warmer global temperatures were when Antarctica started to form its ice sheets. This is actually showing 10 degrees warmer, so it's probably more like in this area when Antarctica's ice sheets started to form. Anyway, they started to form about 33 million years ago. And you can see from this chart that there is clearly zero correlation and zero causality between atmospheric CO2 and global temperatures. CO2 is a trace gas, and it makes up 0.04% of the atmosphere. Speaking of the atmosphere, here's nullschool.net's jet stream imagery. It's the 250 hectopascal winds. Here are the surface winds of the eastern world. Since we showed you the jet streams of the eastern world, there are the surface winds. And we've got actually a windy environment here around the southern geographic pole. See pretty heavy winds all around Antarctica. Antarctica in many ways is the nexus of weather on the planet, folks. And maybe we'll do a special video just about that. As the coldest place on the planet is relevant. Here are the surface winds of the western world. We've got windy conditions in the North Atlantic once again. Here are the 250 hectopascal winds, otherwise known as the jet streams. And we've got some major kinks in the jet stream here, some hot air being injected from Mexico into Texas with this meridional jet stream flow right here. Look at this 180-degree bend over only about 500 miles there. Anyway, that's the jet stream. Here's the lightning situation. And we're on lightningmaps.org. It's where I go when I hear thunder. We've got extremely active lightning here, south of Mexico and in southern Texas. Also some off the coast of Corpus Christi. Here's the global lightning map. Again, lightningmaps.org is a real-time lightning map. It'll even show you the likely propagation of thunder. Convince your friends and foes that you're Thor. And we saw an errant lightning bolt in the middle of the Atlantic Ocean, folks. Check it out. And here's the GOES lightning mapper. Let's speed it up a little bit. Can I speed it up a little bit? I think there's a way. I don't want to mess with it. Anyway, there's the lightning mapper. We're going back like about 5 hours here, I think. So quite a lot of lightning there in northern Mexico and especially southern Texas. A little bit at the bottom of the Texas stovepipe as well. Check out this phys.org article. Now, phys.org's Earth section is rife with sharticles. And here's a hilarious one. Model could create hurricane forecasts up to 18 months in advance. Well, I would just like to take the opportunity to state that you can forecast anything. The question is, will it be correct? What an idiotic idea. We're going to forecast hurricanes 18 months in advance. So, as you may know, Mankind can't even forecast the weather 3 days in advance. But now this ridiculous North Carolina State University research published projected forecasts 18 months in advance. What a joke. Like so many articles in the phys.org's Earth section, rife with crap. Let's scroll down the list. Oh my God, Antarctic ice sheet melting to lift sea level higher than thought, study says. This is my favorite, though. Let's talk about racism in science. How about devolution? The de-evolution, the backward evolution of mankind. You're seeing it happen. So at the same time that part of the human species is evolving and becoming smarter and more sophisticated, a large portion of it is becoming dumber and fully idiotic. The de-evolution of mankind. Speaking of the de-evolution of mankind, how about this article from phys.org's Earth section? Geologists call for action on tackling racial inequality in field. And what they're talking about here is that they need more people of color to become geologists and so on, which, by the way, is racism. Because suggesting that we need more of one race or another race to do anything, as opposed to people doing things because they choose to based on their merit and their skill, talent, and training, is racism. Because it's to suggest that, oh no, we don't have enough Somalian geologists. That is racism. Because what you're saying is that Somalian geologists are more valuable based on the fact that they're Somalian, which means, in effect, that all other races are inferior to Somalian geologists, which is racism. This nonsense about diversity being our strength is just ridiculous. And trying to urge people to take up a field they would not have other taken up is nonsense also. What a pile of crap. Geoscientists call for action on tackling racial inequality in field. Well done. Well done. I'll scroll the article in case any of you would like to pause the video and lose an IQ point by reading this crap. Let's take a look at high seas. And we've got high seas. We're looking at waves right now. And check out how wavy the southern oceans are. The area around Antarctica are not fit for man nor beast right now. And those turbulent winds in the North Atlantic as well as the North Pacific causing some high seas up there as well. Let's take a look. 15-foot seas. 15-foot seas there south of that low pressure system. And we'll advance this. This is the Euro forecast for waves and pressure. The ISO lines there are the pressure. There's where we expect pressure and waves to be tomorrow at noon Eastern Daylight Time. Next, looking at the U.S. Doppler radar map, and you can see those heavy storms stagnating as we forecasted in southern Texas. Yowzers. Some snow continuing to fall. It's May, folks, and snow is falling in northern Pennsylvania, New York, Vermont, New Hampshire. Looks like some freezing rain falling in Massachusetts as well. Apparently the planet is so hot that it's cold. Here's the NASA GOES interactive weather satellite shortwave radiation map, aka the cloud layer when it's too dark to see it with the visible satellite. There's the water vapor map. Again, the cloud layer, the U.S. Doppler radar, cloud layer, and water vapor. And that's today's meteorology segment. Nothing stinks about that. Bye-bye, Twitch. We'll see you next time. Continuing on with bonus features for our daily space weather viewers. Are you spaced out? Have you told your friends and foes about our content? Are you viewing our videos from a different plane of existence, planet, solar system, spaceship, galaxy, universe, multiverse, etc.? Are you an alien? Leave us a comment. Let us know. We've got no bonus features from the National Sunspot Observatory because these images are too old for me to care about. All right, I'll bring this one up. Udaipur, India. It's 17 minutes old. I guess that's still new enough. And I would note once again, folks, we've got filaments down here that could eject. There are some filaments up here as well, I believe. Likelihood for a coronal mass ejection is still there. Not all that high. And we wouldn't expect it to be all that big of one. But in any case, thanks to the SMASH team for tuning in. Thanks to our patrons, the true source of funding for the content, patreon.com/smAshomash. If you want the earliest alerts and so on, as well as all kinds of multimedia, other information, scientific papers that we don't share with anybody else, patreon.com/smAshomash. By the way, I've explained the mechanism behind the solar cycle, not even to our patrons yet. And so look for a paper coming out very soon. We're going to submit a paper for peer review, and then we'll make a video about it once that is a thing. This will expose a fundamental problem with many of the physical sciences, including cosmology, astronomy, heliophysics, and indeed geology, as the implications of it will be vast, and they expose a misunderstanding of the solar sunspot cycles. If you haven't checked out smAshomash.org, you're invited. And we've just recently updated the movie recommendations. We've got a cosmology, earth and geophysics, free-for-all, general science, the sun forum, and a new users forum. So check that out. We'll be announcing the winner of the April Slam Poetry Contest later today. And here come the rest of our bonus features in the form of the high-resolution colorized magnetogram. And I've pressed refresh. We're establishing a secure connection. Here's the intensitygram. And we still can see that's sunspot 2818, I believe it is there. You can see it looks like it's actually degraded a little bit since we even did show prep. There is the colorized magnetogram of that region. And as far as other magnetic organization areas, we see one tiny area up here and one tiny area down here. In other words, we're going to be back into 0 sunspots by the end of the day today. And here are 2 more SDO animations from the Solar Dynamics Observatory. This is 171 angstroms ionized iron. And we'll close things out with a close-up of those active regions in the southwest. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Drink if you like to, but if you do, don't drive. Seriously, don't drive. I could be out there, and I dislike traffic. No matter how much I like you, I still dislike traffic. Visit our links, support the channel. Thanks for tuning in, and may that coronal hole windstream solar wind be at your back.